Good morning. Today we are going to deal with the practical number 5, and that is testing of population correlation coefficient. That is using Z transformation we can test the correlation coefficient, population correlation coefficient. Here again single population, that is H0 is rho equal to rho naught. Rho is the population correlation, then it is equal to rho naught or not, that we have to test, and we have to again test the equality of two population correlations, that is rho 1 equal to rho 2 or not, that we have to test. So here there are, the first question is a sample of 100 students selected at random and their heights and weights are measured, and the correlation coefficient between heights and weights is found to be 0.688. Is it reasonably to consider 0.6 as the population correlation coefficient? That is H0 is rho equal to rho naught is 0.6 or not, that you have to test. For this one, what are the formulas required? So your hypothesis is H0 is rho is equal to rho naught versus H1 is rho naught equal to rho naught. So under H0, what is our Z statistics? So we write it as, actually because it is a Z transformation, we will write it as the statistic as U. U is equal to Z minus Z naught divided by 1 by root n minus 3 as a standard normal VDA. So this is the U statistic under H naught. Now what is your Z? Z equal to half into log of 1 plus R divided by 1 minus R, and what will be the Z naught? Z naught will be population, that is rho equal to rho naught, therefore 1 plus rho naught divided by 1 minus rho naught. So this is the Z and Z naught. So n is the sample size like that way, and using this one you have to obtain the Z statistics or U, and after getting that you have to go for the, if alpha is level of significance, that is 5%, then table value will be equal to 1.96. if it is 1/10 then it is 1.64, like that way. If it is 1% then it is 2.58, 1% 1/10 then it is 2.34, like that way. You have to take the table values and compare as usual, and if calculated value is greater than table, then we have to reject H0, otherwise we have to accept it. Now we'll see the first problem. In first problem, what is given? A sample of 100 students. So question number 1, n equal to 100 is given to you. Their population sample correlation is R, that is given as 0.688 between heights and weights, and you have to test a rho, that is rho naught is given as 0.6. Now what you have to do? You have to substitute this value here. 1 plus R 0.688 divided by 1 minus 0.688, get its ratio, obtain its log, divided by 2, that will be your Z value, and here you have to substitute 0.6 and get the Z naught. Then under H0, what is your test statistics? Z you have calculated, Z naught you have calculated, divided by 1 by root of n is 100 minus 3. So that follows a normal 0. So these values are already calculated from here. Substitute the values in this formula, divided by 1 by root of 97, whatever value you have got. So obtain its absolute of U. It is U calculated, we can say, right? If 5% U table is equal to 1.96 at 5% level of significance. If this calculated value is greater than 1.96, then we say that H0 is rejected. This is rejected means what? The population correlation coefficient is not 0.6. If it is accepted less, suppose it is 1.5, suppose calculated value and table value is 1.96, therefore this calculated is less than this one, therefore H0 is accepted. That means rho equal to rho naught means rho naught is 0.6. The population correlation is 0.6, you can say. So this is your first question. Second question, what are the things given? The second question, a correlation coefficient minus 0.6 7334 is obtained from a sample of 94. N equal to 94. Sample correlation is given as minus 0.7334. And can it be regarded as a sample taken from the population whose correlation coefficient is, that is rho naught is given as minus 0.65. So that you have to test. Again, substitute this 0.7334 here and here. Get its ratio, obtain log divided by 2 will give the z value. Then 0.65 with minus sign you have to substitute here and here. Then minus will become plus and this will be minus. And whatever ratio you are getting, obtain its log divided by 2, that is z naught. So you get the z and z naught, substitute here, z naught divided by n is 94 minus 3, so root of 91. That will be your u calculated and u table will be 1.96. So compare that and give your decision. Question number 3. In question number 3, what is given? The correlation coefficient is 0.82834 calculated on the basis of sample of size 116. Total sample size 116. Correlation is given as 0.8234 and rho naught value. Test whether the population correlation coefficient is 0.5 or not. That you have to test. Again, you substitute this value here and get the value of z. 0.5 in this place and get the value of z naught. Get its subtraction, multiply by r. This divided by 1 upon root n minus 3, or you can multiply by this. And so this subtraction multiply by root of this, what is that? 160 means root of 130 needs to be multiplied to this subtraction. So that is your u calculated. U table as usual, it is 1.96. So these are the 3 questions for the testing single population correlation. Now you have to go for the double. That means you have to test the equality or difference of the 2 population correlations. So that is H naught is what? H naught is such that rho 1 equal to rho 2 versus H1 says that rho 1 not equal to rho 2. So under H naught, what is your Z statistics or U statistics will be Z1 minus Z2 divided by under root 1 upon N1 minus 3 plus 1 upon N2 minus 3 follows a standard normal. So that is your Z. Now what is your Z1? Z1 is the 1/2 into log of 1 plus R1 divided by 1 minus R1. Z2 is equal to 1 by 2 log of 1 plus R2 divided by 1 minus R2. Using this one you can obtain Z1 and Z2, and N1 and N2 will be given in the problem. Now we'll see the next problem as fourth one. 2 different sample of sizes, that is N1. Question number 4, N1 equal to 138, N2 equal to 196. Corresponding correlations, that is R1 equal to 0.7486 and R2 is equal to 0.6890. So these are the R1, R2. Now substitute these values R1 here and R2 here, get the value of Z1 and Z2. Use this formula, Z1 minus Z2 divided by N1 is 138, N2 is 196, and simplify this, get the U calculated and test against 1.96. And what is your question? Is it be reasonable to consider as population correlations are same? If it is accepted, then population correlations are same. If it is rejected, then the 2 population correlations are not equal. Like that way you can give the decision. And the last question is, a psychology test is administered in 2 groups of which 43 and which contains 43 and 48 persons. That means N1 and N2 are given to you as the first group has 43 persons, second has 48 persons. the corresponding correlation coefficients are, that is R1 is given as 0.6742 and R2 is given as 0.3931. So these are the two values. Is the difference in population correlation is significant? Means you have to test whether they are equal or difference is significant. That you have to test. Means rho 1 minus rho 2 equal to 0 or not, that you have to test. Again, everything is given. R1 you can substitute here, get the value of Z1. R2 you can substitute from here to here. 1 plus R2 by 1 minus R2. Get the ratio, get its log divided by 2. That will be your Z2. Once you have got Z1, Z2, substitute in this formula. Get the U calculated and U table will be 1.96. If calculated is greater than table, then you have to reject. That means rho 1 is not equal to rho 2. There is a significant difference. If it is calculated is smaller than the table, then you can say that H0 is accepted. That means there is no significant difference. They are equal. Like that we can give the decision. That's all for this practical of testing the population correlation coefficient. Thank you.